So here is some last minute revision for your paper 3 tomorrow. This is based on the Edexcel higher tier past 2 papers that you've done, paper 1 and paper 2. So here are some of the last few topics that I think are worth having a quick look over before tomorrow. So first of all, we've got compound interest. So Sakira invested £3,550 in a savings account for 3 years. She was paid 2.6% per annum compound interest for the first 2 years. She was paid R% interest for the 3rd year. Sakira has £3,819.21 in her savings account at the end of the 3 years. Work out the value of R. Okay, so I'm straight away going to use my compound interest formula. You get your initial amount or your principal amount multiplied by 1 plus percentage over 100, which I like to just write as a multiplier, so that's technically 1.026. You can write it like this if you want in your formula sheet, that's fine. And then to the power of how long? That was only 2 years though, so to the power of 2. Let's work that out. As you can see, that gives me £3,736.9998. I'm just going to keep all the decimals for now because we're not quite done yet. Technically, we would then take that number, wouldn't we? That would be our new starting amount, our new principal amount. And we would times it by 1. This time I will use the formula because we don't know the interest. Plus R, in this case, over 100 to the power of 1, because it's only 1 year. You don't really need to write that though. To the power of 1. Now, I know that that would equal £3,819.21. So now I've got an actual equation, and we just need to rearrange it to find R. So first of all, I'm going to divide by the 3,700, which gives me a load of decimals here. But if you have a look, after the 1.021, the rest are basically 9s. So I'm just going to round that to 1.022. You could probably see what the answer is from here, but if not, then we just subtract 1. So we're left with R over 100 is just 0.022, and then multiply by 100. So you can see that R should be 2.2%. Question 14, we've got circle theorems. Points B, D, E, and F lie on a circle. ABC is the tangent to the circle at B. Find the size of angle ABD. So let's mark that one. And it does say, in this case, give a reason for each stage of your working. Sometimes it does, sometimes it doesn't. So looking at 4 marks, it will either be maybe 3 marks for working, 1 for the reasons, or 2 and 2 possibly. So you get a slight idea, 2 or 3 marks worth of steps to work out. So we've got 2 things that you can either start with, 40 or 100. Immediately for me, the 100 is kind of shouting that here, B, D, E, and F create a cyclic quadrilateral. So I know that the opposite angles in a cyclic quadrilateral add up to 180. So that would be DBF would be 180 minus the 100. I know it's kind of easy working out this, but I'm just writing it so that you get the method marks. So that's obviously then 80. And that's because, as we said, opposite angles in its cyclic quadrilateral add up to 180. Then what can I do with the 40? Well, I've got a tangent and I've got this triangle DBF. So that's alternate segment theorem, isn't it? And that tells me that 40 is the same as this one. FBC is also 40 degrees. Now, there are different routes that you can take. You could have worked out this other angle in the triangle and then related it to the pink one if you wanted. It's all the same thing, really. And that's because of alternate segment theorem. And then finally, I just need to use angles on a straight line. So the angle that I want is ABD, which is 180 minus the other 2, 40 and 80. That gives me 60 degrees left. And the reason for that is obviously angles on a straight line add up to 180. So there's your answer, 60 degrees for ABD. Question 20, we've got to solve algebraically the simultaneous equations. These are obviously, as you can see, 1 quadratic, 1 linear. So when you have this scenario where it's clearly that one's got a squared and one doesn't, you have to, if you need to, rearrange the linear one in order to substitute it into the quadratic. For this one, I do have to rearrange it because I don't have x or y as my subject. If you already have got x or y as your subject, you can just sub it in straight away. Now, I need to decide, do I want to make x the subject or y the subject? It doesn't matter technically, you'd get the right answer either way. But look at the one you're going to substitute it into. I've got just x squared, or I've got minus 4y squared. Personally, I would rather substitute into the x squared, because that's going to be easier to expand, isn't it? So that's just my personal preference. So I'm going to make x the subject of this second equation. So minus the 4y and then obviously divide by 3. This is a tricky one because it is a fraction, unfortunately. So you see, if x is the same thing as 7 minus 4y over 3, then I can substitute all of that into the quadratic one. So I've got 7 minus 4y over 3 squared minus the other 4y squared equals 9. Now I have an equation with just y, so now I can just expand it and solve it. It's just a lot of rearranging, basically. So expanding this, the numerator is actually double brackets, so don't just square the 7 and don't just square the 4y, because it's not only those two things. It's like that, isn't it? Obviously the 3 at the bottom you can just square. Minus 4y squared equals 9. Now I'm going to expand this, so I get 49 minus 28y minus another 28y. Be careful with the last bit, that does become positive 16y squared. At the same time, I am going to multiply by 9, so that would be, don't forget you need to multiply this one by 9. You need to multiply every term by 9. Technically, this is a term, this is a term, and this is a term. Obviously, the first term, it would just cancel out the denominator, so you're not actually multiplying these values by 9. The second term would be minus 36y squared, and obviously the third term would be 81. So now I can just collect my like terms, at least on the left-hand side. Minus 56y minus 20y squared is 81. Because I know it's going to be a quadratic to solve at the end, I want to have my y squared as a positive value. So personally, I'm actually going to move all three of these terms to the right, because that would make y squared positive, wouldn't it? So I get 0 on the left, 20y squared plus 56y plus 32. Because it is a calculated question, you can just sub it into the calculator if you want. You don't have to try and factorise it. It's up to you which you prefer. You could simplify this by dividing everything by 4 and then factorising it, but I think I'm just going to still use the quadratic formula quickly. And you can see my first value is y would be negative 4/5, and then go back. You don't have to type it in again, just press the back arrow to where it says plus. We're going to change it to a minus or minus 2. Now that's all the hard work. Once you've got one set of values, so y or x first, you then just sub it back in to one of the original equations. Now I don't like to obviously use the quadratic one because that's more complicated, but I'm also not going to use this linear one here. I'm going to use the linear one that I rearranged, because you see how x is already the subject? So if I substitute y in, then I get a direct answer for x. So do that obviously for each y value, 7 minus 4 multiplied by negative 4/5 over 3, and then obviously calculator, which is 17 over 5. Or the other option is with the minus 2. So 7 minus 4 times minus 2 over 3, and that one's just 5. So my solutions are x is 17 over 5 and 5, whilst y is minus 4/5 and minus 2. Question 22. Here are the first 5 terms of a sequence: 4, 11, 22, 37 and 56. Find an expression in terms of n for the nth term of this sequence. So it doesn't say whether it's a quadratic sequence or a linear sequence. However, the clue is, I feel like, in the fact that it's question 22 and not question 10 or something. So from that you can already assume it's a quadratic sequence. The other thing to note is that the difference between them is not the same every time. So again, quadratic sequence. So I have a very specific method to work out the nth term of a quadratic sequence. I know there are other methods. You might prefer a different method. That's fine. If you like my method, go with it. If you don't, stick with the other one. So what I do is obviously work out the first row of differences. So you can see 7, 11, 15, 19, so on. They're obviously all different. So we need to then find the second row, which should be all the same. You can see 4, 4 and 4. Now I just work my way back up on this left-hand side. So these 3 numbers here. You can see my second difference is 4. As long as I remember, if you memorize this, that the second difference is equal to 2a, then that's just an equation I can solve, isn't it? A is 2. Then move on to the first difference, but it has to be this one on the left-hand side. Memorize that that one is always equal to 3a plus b. Because I already know what a is, I can substitute that in and work out b. So b would be 1. And then my final one is the actual first term in the sequence. That one is equal to a plus b plus c. Because I know a is 2, B is 1, I can then just work out C. So C is also 1. Now, A, B, and C represent the formatting when you write your answer. an squared plus bn plus c, so that would be 2n squared plus technically 1n plus 1. And there's my answer. So I just remember these three things: 2a, 3a plus b, a plus b plus c. And there's your answer. Question 23. A race is measured to have a distance of 10.6 kilometers correct to the nearest 0.1 kilometers. Sam runs the race in a time of 31 minutes 48 seconds correct to the nearest second. Sam's average speed in this race was v kilometers per hour. By considering bounds, calculate the value of v to a suitable degree of accuracy. You must show all your working and give a reason for your answer. So in most cases, when it says by considering bounds and give your answer to a suitable degree of accuracy and give a reason for your answer, when you've got all those three things and it's normally 5 marks, they want you to work out both the upper bound of Sam's speed and the lower bound of Sam's speed and then find some kind of value that satisfies both. So let's find the upper and lower bound for both the distance and the time. The upper bound of the distance is effectively whatever it's rounded to, you add half of that on, or lower bound, take half of it away. So half of that would be 0.05 kilometers, wouldn't it? So effectively I'm just chucking a 5 on the end, 10.65 kilometers. And for the lower bound, we're taking away that, so that would be 10.55 kilometers. Then for the time, now this is the one that's tricky because we've got minutes and seconds, we've got it rounded to the nearest second, but the speed is in hours. So we'll have to find the upper and lower bound as it is, and then when we do use our calculation, convert it to hours. So the upper bound would be, obviously the 31 minutes doesn't really change, does it? And as I said, add or subtract half of what it's rounded to. It's rounded to the nearest 1 second. So adding half a second, 48.5 seconds, or taking away for the lower bound is 31 minutes, 47.5 seconds. Now, let's do the upper bound of the speed. Obviously, we know that speed is distance over time, isn't it? Speed is distance over time. So I need to divide, which means I need a mixture of upper and lower bounds. How do I get the biggest possible speed, the fastest speed? Well, that would be the biggest possible distance in the shortest amount of time. So we're going to divide 10.65 by the 31 minutes 47.5 seconds. But as I said, we do need to convert that into actual hours. So not only do I need to convert from minutes to hours, but also seconds to minutes to then hours. So let's work out the time first. I would probably convert, the time would be in minutes 31 plus the 47.5 over 60, because I was obviously 60 seconds in a minute. So this is the decimal for the minutes, but I want it in hours, so I'm going to divide the whole of that again by 60. 0.52, that makes sense, right? Because it's just a bit more than half an hour. 0.52, so there's my answer there. Going to keep that in my calculator. Now I can divide the 10.65 by my answer, and there is my upper bound of the speed, 20 point, let's just write down a few decimals, 0.996. Then do the same, but for the lower bound, we're obviously now swapping everything. To get the slowest speed, I need the least distance by the most time, the longest time, so the complete opposite, 10.55 kilometers. Divided by the 31 minutes 48.5 seconds. And again, we need to go through the process of converting it into hours. So 31 plus the 48.5 over 60. This is now minutes. And then divide that by 60 again. You can see it gives me 0.53 of an hour. Now I can divide my 10.55 by that. And I get 19.9. Obviously, it should be a smaller number than your original one. 19.9004, something like that. So we've worked out both, but we do need to have one answer, the value, just one. So that's when they say to the suitable degree of accuracy, have a look at both. When they ask this question, it should round kind of obviously to one number. If you have a look, they would both round just to 20, wouldn't they? They would both round to 20 kilometers per hour. So I would say, therefore, the speed was 20 kilometers per hour. Now, we do need to give a reason for our answer as well. And you say something along the lines of, to whatever you've rounded it to. So this is either two significant figures. Technically, it's to the nearest 10, isn't it? Technically, it's to the nearest whole number. Technically, it's to the nearest 5. Anything that you've rounded it to, I just went with significant figures because it sounds fancier, but it doesn't really matter. To two significant figures, that is 20, isn't it? Both bounds round to 20. So to whatever you've rounded it to, they both agree. They both round to that number. Some kind of reason along the lines of that. Our final question obviously has to be the harder vectors geometry questions, but this one is a little bit nicer because it isn't one of those ratio questions. If you do want to look at the much harder ratio questions, I haven't put it in this one because I feel like the night before the exam it's probably not going to suddenly make sense to you, if you know what I mean. Like if you're watching this 20 minutes before the exam, it's probably not going to suddenly be a light bulb moment that you understand it. So I've put a slightly nicer one in because I feel like there's more of a chance that you'll pick up this method in the last kind of 12 hours before the exam than you will the other one. But if you do want to look at ratio for vectors, I have got videos on that and I will link them in the description or I'll link them here so you can look at that if you want to as well. So CDEF is a quadrilateral. FE is A, as you can see, ED is B, and CD is 2A. They've already labelled it for you. The point P is such that CEP is a straight line where CE and EP are the same. So you can see there's no P here, so I'm going to just draw that on myself. It doesn't have to be to scale, but it's about there, isn't it? So that would be point P here. They're telling us that CE is the same as EP in terms of the length of it, so that's good to know. Use a vector method to prove that CF is parallel to DP. So again, I'm going to join those two up as well. When you're proving that two vectors are parallel, we first need to find out what those two vectors are. The easiest one is obviously CF. You might as well start there even if you're not sure how to do the other one. Start with CF. Imagine you're stood on the point C. You have to get to F. I can't go down that line because I don't have it. Imagine you can only walk along lines that have actual vectors on them. So I can only go from C all the way along to D, down to E, and then back to F. So I know that I'm going the correct direction to D, so that's just positive 2A. I am, however, going the wrong way down to E, so that's minus B, and also the wrong way from E to F, so that's minus A. So then just collect the like terms as if it's algebra. A minus B. Okay, easy. That's definitely going to be 1 mark at least. Now I want to find the vector for DP so that I can compare them at the end. What I could do is, walking from D, I could come down minus B and then along to P. From E to P, so I need to know E to P, don't I? So for DP, we know it's minus B to start with, but how do I get from E to P? Because I don't have it currently. Well, that's why they told us that these are equal. I could work out CE, couldn't I? Let's write this over here. C to E, you can go this way or you can go this way, it doesn't really matter. I might just do 2A minus B. That's C to E, isn't it? Because CE and EP are on a straight line, they've said that, it's on a straight line, and they are also an equal length, it means they are exactly the same vector. They are the same vector, aren't they? They're just an extension of each other and they're the same length. So that means EP is also 2A minus B. So if you imagine you could go like that and like that, that would still be a 2A and that would still be a minus B. So plus 2A minus B. Now collect the like terms, I get 2A minus 2B. Okay, have a look at both. To prove that two vectors are parallel, once you've actually got the vectors, to prove that they're parallel, you have to show that one is just a bigger version of the other, a multiple of the other. Can you see if you look at the coefficients of A and the coefficients of B, DP is clearly just double the size of CF. It's literally double, isn't it? It has to be the same scale between the A coefficients and the B. So you can see that this was technically 1 times by 2 to make 2. This was technically minus 1 times by 2 to make minus 2. The scale factor is 2 for both of them. So the way that I would write this, you can write that with words if you want. You can say that one is multiple of the other. I prefer to avoid words. So the way that I say it is DP is, whenever you say is in your sentence in your head, that's when you put an equals, 2 times the size of CF, isn't it? Double CF. So that's telling me that it's a multiple, therefore parallel. Because they're multiples, they're parallel. That's all you need to prove. If you want to prove that they lie on a straight line, which obviously these don't because they're not connected, but if they were to lie on a straight line, let's say these two here, CE and EP, let's say they wanted you to actually prove it was on a straight line, well, they are the exact same vector, so the multiple is just a scale factor of 1. But also, more than just that, they overlap at a certain point. So not only are they just random floating parallel lines anywhere, they actually connect. And if you've got two parallel lines that literally connect, it creates one straight line, doesn't it? So if they do ask you that, if they ask you to prove it's a straight line, do exactly the same thing. First of all, prove they're parallel, but then afterwards just write down a little sentence to say they have this point in common, whichever letter it is that they both have. One last tip for vectors though, if you do get a vectors geometry like this where it's drawn and you're not sure what to do, normally the first half of the marks, 2 or 3 marks, is just for writing down different vectors. So for any vectors question like this, even if you're not sure, just start writing down any of the vectors, any of these lines that are not currently defined that you can find out. And then you're definitely going to get at least 2 marks, I would imagine. So again, guys, thanks for joining me today for the last minute paper 3 revision. You've done paper 1 now, you've done paper 2, this is the last one you have to do, and then at least maths is all over with. So best of luck tomorrow, I hope it goes really well. Try not to overthink how well it went afterwards, because there's, ultimately nothing you can do to change it. So just get in there, do the exam to the best of your ability. Don't leave any questions blank if you can, just write down anything that you think might be even mildly relevant to the topic. Just write down anything you can think of, even if you're not sure that it's right. Try not to leave anything blank if you can, and after that exam, just put it behind you and forget all about it and enjoy your really long summer.